Okay, the angle properties of polygons, that is to say shapes with lots and lots of sides, usually from a pentagon onwards, 5 sides, hexagon, 6 sides, heptagon, 7 sides, octagon, 8 sides, etc., etc., relies on one very, very key rule, which I will give you right now. Now, I'm not even going to answer question 2 yet until we've done the basics. So if you imagine I've got, say, for example, a pentagon like that. Again, I'm not answering the question, I'm just talking out loud here. This will be called the exterior angle. I've mentioned this angle in previous vids. Angle. And the remaining one on the inside will be the interior angle. And as you can see, because they're on a straight line, they add up to make 180 degrees. So let's just put a little plus there. That equals 180 degrees. Again, not very beautifully done, but I just want to make the point. Now, it can be shown that, and this is a fantastic rule to begin to learn, this. The exterior angle for any polygon is going to be 360 degrees divided by number of sides. Is that alright? Any regular polygon, 360 divided by number of sides, they all have the same exterior angle, which means if I can work out the exterior angle, I take that away from 180, I've got the interior angle. So here's the second rule. The inside angle, the interior, is going to be 180 degrees, take away the one you just calculated, the exterior angle. Right then, here's another key fact. Working with the pentagon again, I'm not doing question 2 yet, so I've done some ground rules. If I pick, say, this vertex here, a vertex is a corner, so write it down for you. Say this one, I can join that one to that one, and that one to that one. I have got 1, 2, 3 triangles. Now, each triangle has a sum of angles, adding up to 180 degrees, so therefore if I take up these 3 triangles I could work out the sum of the interior angles of a regular pentagon. So basically 3 times 180 degrees, 540 degrees. Alright, so whereas before we were working with quadrilaterals, that is to say 4-sided shapes, we know they add up to 360. And let me just prove to you why again. Any random 4-sided shape, pick a corner, say that one, and I've got 2 triangles. That's why I've got 2 lots of 180 coming to 360 degrees. But with 5 or more, we can get more triangles out of it, and therefore more multiples of 180. A 6-sided shape, let's hope I've got some space to do it here. 1, 2, 3, 4, 5, 6. There's a hexagon. Pick a corner, you to you, you to you, and you to you. Look, 1, 2, 3, 4 triangles, 3 lots of 180. I know that comes to 720, not because I'm clever, so I've got years of experience of doing this. So there we go. As you can see, the more sides we add to our polygon, the greater the number of corners on the inside, the greater the number of angles, therefore the more and more triangles you can get out of it, therefore the bigger the sum of the interior angles. Alright, so these are rules you've really got to focus on. So let me highlight them. Exterior angle, 360 over number of sides. Interior angle, 180 take away exterior angle. And have you noticed, look at this, it's 5 sides, 3 triangles, 4 sides, 2 triangles, 6 sides, 4 triangles, 10 sides, 8 triangles, 15 sides, 3 triangles. How many sides you've got in your polygon, if you take away 2, that's how many triangles you get. And then you multiply that number of triangles by 180 to get the sum of the interior angles. I think I've said enough. Let's actually do a question. Question 2. Calculate the angles marked A and B in the diagram and explain how you work them out. Okay, I think I will. Well, what have I got here? 1, 2, 3, 4, 5, 6. Okay then, I've got 6 sides, I've got a hexagon. I've worked out the hexagon's interior angles add up to 720. I'm not just going to write down 720, I'm going to treat it like an exam question and do this. I'm going to say first of all 6 take away 2, I've got that many 180 degrees. Is that alright? So I've got 6 sides take away 2 sides, gives me 4 sides. 4 times 180 is your 4 triangles, and there it is there. I did it earlier. So and now I'm going to work out 4 times 180 degrees, which is 720 degrees. Now I've proved that the interior angles add up to 720. I can now work out angle A. So now I can do it. A degrees is going to be 720 take away this little lot. Now I've got to write them down. Right, straight into the answer. Hope it works. 720 take away U. So 110 and 120 and 95. Oops. Start again. Press the wrong button. Right, 720 take away 110 and 120 and 95 and 150 and 135, and I've got 110 left. So angle A is 110 degrees. Now angle B is easy. I told you from before the exterior angle forms a straight line with the interior angle, so it's going to be the 180 take away the 135 on the inside, and that will give me therefore, I don't know, 45, I suppose, 45 degrees. And as an explanation for that, you would say angles on a straight line add up to 180 degrees, and I suppose that will be fine for that one. So that's question 2. Let's go to question 3. A regular polygon has an exterior angle of 60 degrees. How many sides do I have? Okay, I think I will do it in red after all. Okay, exterior angle. Here's the rule. Equals 360 degrees divided by the number of sides. I don't like that hash, it's horrible. Let's put the word sides. So here I go. So 60 equals 360 divided by, I don't know, n for sides. Rearranging it, the number of sides has to be 360 divided by 60, and that's exactly 6. And there I go. I've got 6 sides. Therefore, it's going to be a hexagon, isn't it? It doesn't ask me to name it, but I will do. 6 sides. And I've proved it using that lovely rule there. Now, question 4 plays around with this rule. It says, calculate the difference between the interior angle of a regular decagon, 10 sides, and the interior angle of a regular nonagon, 9 sides. Right, I've got to work out the interior angle for the 10-sided and 9-sided shape, and then take them away. That's what difference means. Very unusual question, but really playing with this rule. Remember, if you work out the exterior angle first, then subtract from 180, then we've got the interior angle. So let's go. Let's play with the decagon first. I'm going to work out the exterior angle. What's that? It's going to be 360 divided by 10, which equals 36 degrees. And therefore the inside angle, the interior angle, is going to be 180. Take away the 36 degrees. That leaves me with 144 degrees. That's on the inside of a 10-sided shape. Please note, I don't have to draw it. I can just use my rules. Now let's just do the nonagon. Exterior angle. That's going to be 360 over 9. Well, I can see that's going to be 40, because 9 is going to 36 4 times. So 40 degrees. So therefore the interior angle is going to be 180 take away 40. That leaves me at 140 degrees on the inside. And it asks me the difference between them. So here I go. So the difference is going to be 144 degrees. Take away the 140 degrees, and the difference is therefore a whopping 4 degrees. Alright, I think I'll stop there. That's enough detail, and I'll see you in part 2 of the same section, 7.3.